Hi, I'm Randy Barnett for Fluke, and with 35 years of experience as an electrician, I've ended up as a power quality expert and electrical trainer. And in this video, I'd like to talk to you about your electricity bill. Right now, maybe you just would like to reduce it, and all you really know is how much you have to pay every month for electricity. What you really need to know is, where does all that electricity go? And if you're going to determine that, you need to measure some values. Some information like your total energy consumption in your facility, power factor, and peak demand. Some of the energy logging steps we will take today to help you streamline your energy consumption are: identify large loads, log at service entrance and log each large load, compare log data to the utility bill and address the issues that are revealed. Review your kilowatt hours, peak demand, and power factor charges. Depending on your agreement, you may not be paying power factor penalty charges. Other charges, such as customer administrative charges, fuel adjustments, tax and franchise fee, and time of day charges, should be reviewed. You are charged for your demand usage in addition to the kilowatt hours. Demand is the amount of electricity used over a period. Power factor reflects how efficient you are with the electricity supplied. As you can see, the Fluke 1735 Power Logger collects the same data that you saw on your power bill. The top half of the Power Logger screen shows demand, or kW. The next screen shows kilovolt amps, or kVA, on the bottom. The corresponding MVA value is shown at the top. The next screen shows the kilovolt amps reactive, or kVARs, and on the next screen, power factor is shown, the key parameter we're trying to maintain. Now, let's talk about where to log. I recommend using a one-line diagram to visualize your plant distribution system. Your job is to find the loads drawing the most power. Log power at or close to the service entrance at a safe location. Always make sure of the nominal system voltage before going into a panel. Always select your PPE for the job based on the warning labels on the equipment. If the labels are not present, use the tables in NFPA 70E to determine the appropriate hazard risk category and the required protective equipment. Here you can see inside the main cover to show you exactly how connections are made. Be sure to connect leads to the proper phases and make sure the arrows on the current clamps point towards the loads. This is where color coding your leads can help. Connecting inside any live panel is tricky and is to be done only by qualified persons. Make sure you are using your voltage-rated tools in addition to wearing your PPE. When you do this, you will most likely be lying on your back in your flash suit, wearing your gloves, reaching up to connect, as you can see here. It can be awkward, so be careful and follow safe work practices. Be especially alert for extremely high arc flash incident energy levels at service entrances. You may have to go downstream after the service disconnect or main breaker to log values. Once you've completed your connections, always make sure to check your setup and verify that connections are correctly made. When you're preparing to leave a logger behind for an extended time period, you want to make sure you're capturing the correct data. You can check this by turning the dial on the Fluke 1735 Power Logger to meter. The Fluke 1735 Power Logger automatically captures all of the major power parameters while it logs. In this case, we care mostly about kW, kWh, peak demand, and power factor. It's managing these values that will save you money. Start recording and walk away. You want to capture the full demand cycle if at all possible. In particular, we want to use less energy at times when it's the most expensive. But we also want to see how much we're drawing during the middle of the night to see if there are things we could shut off and see what our power draw looks like when multiple loads are working simultaneously. Later on, we'll use this data to see if we can change our operation to use less energy. You can leave your logger collecting data for days. When you're done logging, come back, terminate the recording, and check the data on your logger to verify you collected the data you wanted. You can download your first power recording and take a quick look on your laptop, or you can proceed directly to another large load and start logging there. I recommend taking a look because it's worth checking if your kW draw is as high as compared to the utility. If you find that your kWs are high, compare the log data to your operating schedule. Is there a correlation to a particular load activity? If yes, you know where to hook up your logger next. Keep moving your logger downstream to large loads and find out how much energy they are consuming. This compressor is a good example of a load that's big enough to cause problems with your electrical bill. Again, make sure you are wearing the proper PPE for the job. Always stand to the side as you open and close your doors. Connect your color-coded voltage leads to the correlating connections. Connect the flex current clamps to the matching connections, making sure that all connections are correctly made. Flexible current clamps can be ideal for hard-to-reach locations. Once you've completed your connections, go to the power screen and make sure your leads are detected and your configuration is correct and power is being measured. When ready, push the Measure Record button. Hit Enter to accept the warnings that previously recorded data will be lost. The logger clears its memory and begins recording data. Notice when your peak demand occurs and compare it to your operational schedule. These charges can be managed effectively by analyzing the data from your power logger. When you're done with all of your logging and you've downloaded your data from your power logger into your computer, sit down with your utility bill and your operating schedule for that same period. Here are some things you need to look for. Learning to manage peak demand and power factor are two of the quickest and easiest ways to save on your electric utility bill. By correctly analyzing the data from the Fluke 1735 power logger, you can determine the best time to operate large loads and where to add power factor correction capacitors. The result? Money saved. So now that you know how much electricity you're using every month and where all that electricity is going, you can start making some decisions in order to reduce that monthly electrical utility bill. You're going to have to record some data. Use the Fluke 435 Power Quality Analyzer and the Fluke 1735 Power Logger. Then you can analyze that data and, down the road, you can make some more intelligent load management decisions. For Fluke, I'm Randy Barnett.